All right, today I want to show you a very brief one. We are still looking at integration. Integration. Integration just needs you to follow a very simple step. A very simple step. So if you are told now, say solve the differential equation. If you are told to solve the differential equation, the simple thing you ought to do is, for example, you are given dy over dx. A dy over dx is equal to 5x cubed plus 2x squared plus, say, x plus 3. You are told to solve this differential equation. So the first thing, like I told you, you have a very simple method that you ought to follow. You consider the power. You consider the power. So what you are going to do is you put down 5x. So considering the power, you are going to add 1 to whatever x is raised to the power. So since we have x raised to the power of 3, so we are going to say what? 3 plus 1. And what you are adding to the power, the 3 plus 1, you bring it down, you're going to have what? Also, you're taking down the what? 3 plus 1 as well. And plus 2x 2 plus 1 divided by what? 2 plus 1 plus. Then we have an x here that is standing alone. It is more or less, when you see it this way, it is raised to the power of 1. It is raised to the power of 1. So what you are going to do, you say x 1 plus 1 divided by 1 plus 1 plus 3. So because you are integrating, you are actually integrating each part of the equation with an x. You are integrating each part of the equation with an x. So you are going to add x to 3 that is standing alone. So we go ahead. So we have the 5. This is what? X raised to the power of 4 divided by 4 plus 2x raised to the power of 3 divided by 3 plus x raised to the power of 2 divided by 2 plus 3x. Then you add the c plus the c. This is now supposed to be your final answer. That's supposed to be your final answer. So I'm going to take another one. I will take another one that will help us to get to understand it better. So I'm taking this out now. So we say solve the differential equation. Let's say 4x 3 plus, let's say 2x square 2x square plus 2x plus 5. You are told to solve this differential equation. We follow the same procedure by integrating each side of the equation with an x. So then you also consider the power. So we bring down 4. We have x 3 plus 1 divided by 3 plus 1 plus 2x 2 plus 1 divided by what? 2 plus 1 plus 2x. Remember I said that this is 1. So you have what? 1 plus 1 divided by 1 plus 1 plus 5x. This will now become what? An x. So you add plus c. So we can go further. We have 4x raised to the power of 4 divided by 4. 3 plus 1. 3 plus 1 gives you that 4. Plus 2x raised to the power of what? 3 divided by 3. That's 2 plus 1, 3. 2 plus 1 here, 3. Yes, good. 2x raised to the power of 1 plus 1, 2. And here, what's 2? Plus 5x plus c. Now, if you check very well, you can break this further. You can break it down further. So you go ahead, you say, this divided by this, that is gone. That is 1. So we can't do this further. We leave it this way. So we take this out, we take this out. And so what we are going to have is what? X raised to the power of 4 plus 2x cubed divided by 3 plus x squared plus 5x plus c. And now that gives you your final answer. That gives you your final answer. I hope that is clear. I hope that is clear. So let's take another example. Let's take another example, and the one we are going to be looking at now is the property of indefinite integral. Property of indefinite integral. Let me quickly write down out. Property of indefinite integral. Property of indefinite integral. That's what I'm going to be taking very quickly. Okay, so what we're expected to do in this one, I'm going to take, I think I missed something, I'll bring it back. So this is what we are going to do. So if you have, sometimes it'll be written like this, say find the following. Find the following. So what you are expected to do in this case, and you say the integral, this sign that looks like an X is what? Integral of, in bracket 5 x raised to the power of 10 minus x raised to the power of 8 plus 2x dx. So what you are going to do in this case, you are going to what? Integrate each part of the equation. Integrate each part of the equation. Integrate each part of the equation. So what you will do here is you're going to have what? 5x 10 plus 1. Okay, let's do like this first. You integrate each part, 5x raised to the power of 10 minus the integral of x raised to the power of 8 plus the integral of what? 2x. All dx, all is supposed to have a dx minus, then this is going to have a dx plus, and then a dx plus c. Yes, awesome. So now we are going to consider the powers. We consider the powers. So we do the same thing, x 10 plus 1 divided by 10 plus 1 minus, you bring down the minus, then we have x 8 plus 1 divided by 8 plus 1. You bring down the plus 2x. Remember, this is 1, so this is 1 plus 1 divided by 1 plus 1 plus c. Here you bring down the c. So you go further, you are going to have 5x raised to the power of 11, 10 plus 1, 11, divided by 11, 10 plus 1, 11, minus x raised to the power of 8 plus 1 will give you 9, divided by 8 plus 1 will give you what? 9, plus 2x raised to the power of 1 plus 1. So you have 2x, 1 plus 1, which is 2, divided by what? 2 plus c. Now let's look at it. We can break further. There's a part we can break further. We can take this down. So we take this and we take this. So our final answer is going to be 5x raised to the power 11 divided by 11 minus x raised to the power of 9 divided by 9 plus x squared plus c. So that's your final answer. That's your final answer for that part. Very straight to the point. Very straight to the point. So I like to take another example. I'm going to take another example. I like to take another example. So, for example, you have, you say solve the following. Solve the following. The integral of x raised to the power of 3 over 2 dx. This is a very beautiful one. X raised to the power of 3 raised to the power of 3 over 2 dx. Now, if you see the power of x, now the power of x, let me put it this way, xn, so here n is equal to what? 3 over 2. in this particular case. So we are going to integrate this particular equation just has one part. So we are going to take care of the one part. Like we always do, n is actually going to be added with 1. So what you do now, you're going to have x 3 over 2 plus 1 divided by 3 over 2 plus 1. 3 over 2 plus 1. That's what you are going to have in this case. But what we are going to do now is we have to separate that 3 over 2 plus 1. We bring out the 3 over 2 plus 1 and we take care of it alone. So what do? We are going to work out it this way. We work it out this way. So let's do like this. So this is the part I want to use now to sort this out. So this is 3 over 2 plus 1. Now, the left-hand part is a fraction. The right-hand part is an whole number. So I need to make the both of them a fraction. So I'm going to say divided by 1. So I've made both sides a what? A fraction. So what I should do further is I'm going to find the lowest common multiple. There's a common factor. I'm going to look for a common factor between 2 and 1. The common factor between 2 and 1 is 2. Common factor between 2 and 1 is 2. So I said divided by 2. So now 2 divided by 2 is 1. 2 divided by 2 is 1. So this way 2 divided by 2, you get a 1. So this 1 will multiply this 3. So 3 times 1 is what? 3. So I write it down. I bring down the plus. So now 2 divided by 1 is equal to what? 2. So this is 2. So this 2 times the 1 that is up here, the other part of the fraction is what? 2. 2 times 1 is 2. So I bring the 2. So I'll have what? 3. 3 plus 2 is what? 5 over 2. I hope we got that now. So 5 divided by 2. So I'm taking this out. So you have 5 over 2 as your value. Remember, you need to add a plus c. So we can now go ahead and say what? X raised to the power 5 over 2 divided by what? 5 over 2 plus c. Did you get that? 5 over 2 plus 5. X raised to the power 5 over 2 divided by 5 over 2. That's where we are actually supposed to get to in that aspect. But now the question is, can we break this down further? Can we take it down further? That's the question. No, that is where we ought to stop in that particular part. I hope that clears the point. So I'm going to bring forth another example. Let me bring forth another example. If we have, say, solve the differential equation. dy over dx is equal to 4x squared minus 1 over x squared. This is a very beautiful one. And I want you to look at it very carefully. So this is 4x squared minus 1 over x squared. Minus 1 over x squared. So what you are going to do here is you are going to say this is different from this. So I'm going to show you a very simple way to handle this. So what you will do is this is going to be 4x 2 plus 1 divided by this 2 plus 1. 2 plus 1 minus 1 over x. 2 this time is an inverse of it. So you are going to say what? Minus 1. Did you see that? plus c. Whatever the part 1 over whatever it is raised to the power, you are going to subtract from 1. Unlike the other case that is up, you add 1 to it. So very short way, straight. You don't need to do too much things. So here you are going to have 4x raised to the power 3 divided by what? 3 minus 1 over what? X. So you know 2 minus 1 is what? 1 plus c. So this is your final answer. This gives you your final answer for this particular one. This gives you your final answer. Now, how about somebody may now ask, how about having it this way? How about having it this way? For example, this is 3, and this is 3. For example, so I'm going to try 2 more or 1 more. Yeah, so if we have 4x cubed minus 1 over x cubed, how do I solve this? Simple, same way, the same process. So I say 4x, 3 plus 1. The power always raised to 1. So bring down this part, 3 plus 1 minus, bring down the minus 1, x 3 minus 1. The inverse is going to be a minus 1 because this is down, the other one is up. Do you get? So then the plus c. So we have what? 4x raised to the power of 4. 3 plus 1 is 4. And here 3 plus 1 here is what? 4. Minus 1 over what? X. This minus this is what? 2 plus